Today we study X16Q, and in the Korean version X16QK. I have explained a lot regarding the problem, so perhaps it's better to concentrate on how to make use of reduced program to compute algebraic analytic computation. Okay, so please refer to X16QK and elementary explanation regarding these problems in given in X16NQE. Okay, so the reduce is a program to allow us to carry out algebraic computation. It also carries out the floating point computation that is allowed by most of computer programs. So let's see. This is the Reduce is a public programming now. A long time ago, when I used this program more than 30 years ago, before the advent of Mathematica, it was a rather expensive program, but now it is public. So you can visit here. You can type in Google reduce 3.8. If you type reduce only, there are so many. It is irrespective of the reduce program. So please type reduce 3.8. So if you visit this place, you can download the program. And there is a manual. So if I click this, you'll find the manual reduce program. It's written by A.C. Hearn, and most of the computer algebra program is written by theoretical particle physicist, and the first one is Schoonship, Nobel laureate. Beltman wrote it. All right. So let's see. Let's compute this simple calculation, integration of sine of x. We usually make use of we usually compute it by hand or memorizing the integral table. This time, let us make use of reduced. Okay, we have sine of x. Why don't we define f equals the sine of x? Okay, this is sine of x is some function, built-in function of a reduced program, so it understands what sine of x is. When you write a sentence, you might want to end with the semicolon. If I do not write it instead dollar, then the output doesn't appear on your monitor. So in case we have a very, very complicated expression like x to the 300, something like that, it takes a long time. I don't remember whether it understands this or not. Let me try. Oh, okay, it understands. So it takes a very long time. But as you can see, in most programs of Fortran, or perhaps you do not know what Fortran was or is, but in most cases, numerical calculation is carried out with a fixed floating point. But as you can see, all of the binomial coefficients are exactly computed in here. There is no approximation at all. So this is a kind of computer algebra. Okay, so why don't we make use of this to carry out integration or differentiation. Oh, wait a second. F equals sine of x. df of fx. What's that? You're familiar with it. This is the derivative of a function. So sine of x derivative is cosine. Do you know f? What about the f1 equals cosine of x? What is the derivative of cosine of x? Okay, minus sine x. It took a very long time to derive this integral table when you studied for the first time, but computer knows how to compute. Okay, this is a way to use a reduced program. So now we are able to take the differentiation to find the derivative. So why don't we integrate? So int f, what is f? F is sine of x. int f x. So the answer is minus cosine of x. That is the indefinite integral antiderivative of the function f of x, that is called sine of x. Okay, so I can make use of this. I can also repeat the integral, double integral, or something like that. Anyway, if I finish this integration, perhaps I'd like to evaluate the definite integral instead of indefinite integral. In that case, I'd like to substitute the upper limit and substitute the upper limit in here and then subtract it by the value evaluated at the lower limit. Oh, okay, so let me say fa equals substitute x equals b for the previous one. Okay, so I find this integral, indefinite integral, is a minus cosine of x. Now I substitute b for dx, so the answer is a minus cosine b. What about the lower limit? Copy. Stop means a substitute. Now we have the lower limits value. Subtract the value at evaluated the upper limit by that evaluated at the lower limit. So our final answer for this definite integral is f b subtracted by fa. Okay, so let's see. So cosine b. Wait a second, f of b. Okay. Let's see. I have a flipped. AFA should be the value evaluated x equals a instead of b. So I have sign mistake. Okay, this is a opposite. So the correct answer is cosine a minus cosine b. Okay, so this is a way to make use of reduced program to evaluate the integral or derivatives. Previously, I told you that Wolfram Mathematica allowed us to you have a free program, trial program for this, perhaps a six weeks, something like that. But this program is very expensive. But if you are in a mathematics department, for example, in our school, mathematics department has its psych license, so you can use it. So I frequently use this, so I have a license, but I'm not allowed to let you use my license. So this is a mathematical program. So I integrate. In this case, the we have different grammar. Integrate, you have to write it in the capital letter beginning with the capital I instead. And the sign of X it should be written. There is a mathematical understands distinguish uppercase and lowercase. However, reduce doesn't care whether it is a capital letter or not. So you can integrate over X and lower limit, upper limit. Let's see. What I typed is shift plus enter. You obtain the final result for the. Okay. So what about the derivative? Sine of x. Oh, cosine. What about cosine's derivative? Oh, let's see. Why don't you take the derivative twice? And I use it this way. Aha, double derivative of sine of x is minus sine of x. So, what about if I have some power? A little bit complicated, but it really understands the power n that is implicit. So for any n, it does produce the result. So it's fascinating. Why don't we simplify this result? Percent means the previous result. Okay, it factorizes. Why don't we try a little bit? Do you know how to some sigma? Do you have sigma k runs from 1 to n k. This is 1/2. Do you remember n plus 1? Okay, you can derive this, but you could this is for the talk I will give tomorrow at the KPS meeting. Okay, and here sum k runs from some over there, if I remember correctly. Let's see if it is correct or not. Okay, that's fine. My memory was correct. It's 1/2 and plus 1. So what about k squared? It's 1/6 n plus 1 to n plus 1. Let's see. Sigma k squared. K runs from 1 to n. That is 1/6 n plus 1 to n plus 1. Am I right? I can make a mistake. But computer doesn't make mistake if I order correctly. Let's see. Okay, it's alright. So it is as a fun. And if you just do not think anything and just obedient to computer output, then it won't be good. But if you think and if you make use of computer for a very tedious job, it will be still fine. So I think you don't have to feel guilty to make use of this computer program as long as you think. All right. And actually, all of the figures, or most of the figures that drawn in our K-pop series textbook has three-dimensional figures. It's not just a cross-sectional view, something like that. It is a three-dimensional one, mostly generated by mathematical program. Okay. All right. Just like this figure. Okay. Okay, so we can consider problem two, but because the details of about this solution is given in the Korean version and X16NQE, so I think I don't have to explain further. If you have some time, please, why don't you try to make use of some computer program? Many of our students are not familiar with some math, then it will be a nice chance to have such a fancy experience. And I hope you could enjoy the computer program to save time. And I don't say just follow the computer, but you order the computer and you check your own hand calculation with computer. Okay, that's it for today. Thank you.